So we're going to do thin layer chromatography, or TLC. And we're going to use the most common system for drugs. It's meant for basic drugs, but most drugs are basic, so it tends to be a good screening technique. We're going to use silica gel, 250 micron thickness silica gel. And you'll see that it says F254, and that means that in addition to the silica, there are inorganic compounds doped into the plate that are fluorescent at 254 nanometers. And so when there are spots on the plate, they quench that fluorescence and they show up as dark spots under a fluorescent light. So in addition to using a specific type of silica plate, we're also going to use a specific solvent system and treat the plate in a specific way. The Clark's TA system uses as a solvent system a ratio of 100 to 1.5 methanol and ammonia. And it uses that silica plate, but it also assumes that you've made the silica plate basic by spraying it or soaking it. And I'll show you that in just a minute. So what we mean by 100 to 1.5 is that if you want to make 100 milliliters, you add 100 milliliters of methanol and then add 1.5 milliliters of ammonia. If you want to make 200 milliliters, 200 milliliters of methanol, 3 milliliters of ammonia, etc. We have some for you today. When you're working on your unknown, you'll probably need to make it on your own. And in that case, you'll want to make at least 200 milliliters. By the way, the composition of this Clark's TA solvent and the conditions of the system would make a really excellent pre-lab quiz question. Now, when you're all set, you decide you want to use Clark's TA system and you want to really get this chamber going, because pouring about 200 milliliters is a good amount. But you want to get this chamber going as soon as possible, because it's very important that the chamber fill with fumes before you use it. So really, you want to pour in the solvent, cover it with this top, and then you want to let it sit there, ideally for about an hour, but for really as long as you can. Really, just get it started when the first thing and let it equilibrate while you're doing everything else. So in the Clark's TA system, you don't use the 250 micron silica plates as is. You need to wet them with 0.1 molar sodium hydroxide. And a good way to do that is to use these spray systems where you pour into this container. You pull out the straw, put it in the bottom of the spray head, screw the spray head on the top, and then spray down the plate like you're doing sodium hydroxide graffiti. So make sure to soak the plate. Now really, before you've done this, you want to get a hot plate going, just warm. If it's, you don't want it to be too hot, but you want to be at usually set around 2 or 3. But you want to be able to still touch it. If it's too hot, it'll actually crack the glass. So after you've wet it really nicely with the 0.1 molar sodium hydroxide and made the plate basic, it's going to dry much faster if you put it on a hot plate set just to be warm, not too hot. Again, the plate will crack if you have it too hot. So after your plate is all set, you want to go ahead and mark your plate gently with a pencil. You want to mark the origin. Now, where you mark the origin depends on the depth of the solvent. I would suggest at least 25 milliliters up from the base of the plate, 20 to 25 millimeters. And then you're going to draw a straight line across. That's going to be your origin. And then draw a spot every 10 millimeters. So on these larger plates, you should be able to get 9 spots. And on the smaller plates, you should be able to mark off 4 spots. So when your plate's all marked up and you're ready to spot your sample onto the plate, I like to use these small pipette tips, and you want to just barely touch, and you really want to make the smallest diameter spots as possible. Now you want to repeatedly spot in the same place. And one handy trick that you can do is to keep that hot plate that you used earlier to dry the plate after you made it basic, keep that warm, and then spot it on that plate. Again, don't make it too hot, all right? Keep it warm. But then when you repeatedly spot, they're going to dry faster, you're going to get smaller diameter spots, and it's going to go faster. But you want to load up that gel with a good amount of material. And of course, don't touch the hot plate with your fingers, although it shouldn't be hot enough to burn you. It should just be kind of warm if you're using it properly. So when you're ready to load your plate in the chamber, I like to make sure, hold it up to the bottom level and make sure that the solvent isn't going to come above your origin. If you put the plate in and the solvent comes above your origin, the experiment's ruined and you really just need to start again. Don't try and get away with doing that. It won't work well. It'll be at a little bit of an angle, so it'll go higher than you think. You place it in the chamber. If you have a nice set of fumes built up, it should move relatively quickly and be done somewhere between probably 20 minutes and an hour. So when the plate's all done, you want to pull it out of the chamber, and this is a good place to stop it. If it hits the top, again, the plate's ruined. You can't have it hit the top. So you want to pull it out, and the first thing you want to do pretty quickly is to gently with a pencil mark the frontier. Mark that wet frontier right there. So an easy way to visualize your spots on the plate is to use a UV lamp and take advantage of the fact that the plate is doped with fluorescent inorganics. But you have to make sure that you use a lamp that emits light at 254 nanometers. So you want to make sure that it's the UV lamp that says 254 nanometers on it. Otherwise, you won't get good results. So a good place to do this is in the balance room because you can close the door and it can get dark. Turn the light on. Turn the fluorescent light on. Turn the light off. And then you can visualize the spots. Gently circle them with a pencil.
It blows.
Another good way to visualize things is the marquee reagent. Now, this is a very common color test for visualizing a variety of drugs. It's very dangerous. Be cautious when you use this. It's basically concentrated sulfuric acid. Specifically, it's 100-to-1 sulfuric acid formaldehyde. And you can immerse your plate in there, and for a lot of different drugs, it's going to create a specific color spot. Now, for safety reasons, it's a good idea to pretty quickly put it into water. And be careful here. You certainly don't want to get near the marquee without gloves. You want to make sure if your gloves do come into contact with the marquee that you change them out. You obviously want to do all this work in a fume hood. It's a very effective reagent, but you do have to be careful with it. Even after you've kind of neutralized it with the water there and you still have your colors, you want to be cautious not to touch it with your bare hands. After you've visualized your sample with the fluorescence or the marquee, you can do fluorescence, mark it with a pencil, and then do the marquee. Then you're ready to calculate RF values and analyze your plate.
Marquee, marquee, marquee. Marquee is on the quiz.